Data analysis is the process of inspecting, cleaning, transforming, and interpreting data to discover meaningful insights, patterns, trends, and relationships within it. This analysis is typically conducted with the aim of making informed decisions, solving problems, or gaining a deeper understanding of a subject matter. It involves applying various statistical, mathematical, and computational techniques to extract valuable information from raw data. In our increasingly data driven world, data analysis has become the cornerstone of decision making in various industries, ranging from business and healthcare to science and technology. It is the process by which raw data is transformed into meaningful insights, helping organizations and individuals make informed choices. Data analysis begins with the collection of relevant data. This initial stage involves identifying data sources, gathering information, and ensuring data quality. Often, data collected can be messy, incomplete, or contain errors, which necessitates pre-processing. Tools like Excel, Python libraries such as Pandas, and data cleaning software help clean, structure, and prepare the data for analysis. Once the data is cleaned and ready, the exploration stage commences. Here, analysts seek to understand the dataset's characteristics, relationships, and patterns. Descriptive statistics such as mean, median, and standard deviation provide initial insights. Visualization tools like Matplotlib, Seaborn, or specialized software like Tableau or Power BI create graphs, charts, and heat maps, making data more accessible and facilitating a deeper understanding. With a firm grasp of the data's structure, analysts move on to modeling and analysis. This stage employs statistical techniques and machine learning algorithms to extract actionable insights. Statistical software packages like R and Python with scikit-learn or stats models are commonly used for hypothesis testing, regression analysis, and clustering. For more complex tasks, machine learning frameworks like TensorFlow and PyTorch come into play. This stage not only uncovers patterns but also predicts future trends and outcomes. The culmination of data analysis is the interpretation and communication of results. Analysts extract meaning from statistical findings and model outputs, translating them into actionable insights. Effective communication is vital, and tools like Microsoft PowerPoint, Excel, or data visualization platforms like Tableau and ClickView help create comprehensive reports and dashboards. These visual representations make it easier for stakeholders to comprehend the findings and make informed decisions. Data analysis is an iterative and multifaceted process that plays a pivotal role in today's data rich world. It stages from data collection and pre-processing to exploration, modeling and interpretation, demand and combination of skills, and the use of various tools and softwares. Data analysis is not only about crunching numbers but also about revealing the hidden narratives within the data. As our reliance on data continues to grow, the ability to navigate these stages and effectively utilize data analysis tools becomes an invaluable skill for individuals and organizations alike. It empowers us to harness the full potential of data, unlocking insights that drive innovation and progress in virtually every aspect of our lives.